Course 3, Lesson 68, we are looking at the probability multiplication rule. The first thing, though, that we'll look at is certain outcomes. So if we are looking at how many outcomes, how many outfits can this person wear? Well, she has 2 shirts and 3 skirts. So how many different outfits could she have? Well, in this case, we would say for each shirt, she could have a skirt. So if we go this shirt can go with the red, the blue, or the green. And then the tan shirt can go with the red, blue, or green. Meaning that there are 6 different outcomes. Well, interestingly enough, 3 times 2 is 6. Let's see if it works together. And for here, now we have 3 skirts and 4 shirts. Well, in this case, we can say, alright, this skirt and these shirts, we will have an option. Now we have a blue skirt and these shirts. And lastly, a green skirt with all 4 different shirts. Although yes, of course, some of them will clash, might not pick them together. We have all of these options. And we can think, okay, at the end of the diagram, we have all the possibilities. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Interesting again that we have 3 options and 4 options. When we multiply them, we get our total number of outcomes. Okay. So, in this case, we had 2 skirts, 3 tops, we had 6 outcomes. 3 skirts, 4 tops, 12 outcomes. 3 breads, 5 fillings, we would have 15 outcomes. And lastly, 12 flavors and 6 toppings, we would have 72 outcomes. This is called the fundamental counting principle. The number of options in the first part multiplied by the number of options in the second part will tell me the total number of outcomes. We can do this with more than just 2 things. Okay? But in this case, if we flip the coin and roll, well, we have 6 possibilities and 2, so we have 12 total. A spinner and a dice, we have 6, and it looks like 8, so we have 48 possibilities. And 2 dice, we have 6 and 6, so we have 36 possibilities. 36 different outcomes when we do each of these. Okay, how about this one? We need 1 from each part. So we have 3 sides, 5 plates, 2 desserts. So if we take 3 times 5 times 2, we will get 30 different meals that we could make with taking 1 from each of these. And that's the key here. For each of these options, we can only take 1. We couldn't do an onion soup and a Greek salad and then one of each of the other ones. That would be something different. In this case, we're just taking 1 from each. We'll do a few more examples here. 2 number cubes are rolled. How many possible outcomes are there for which the first roll is even and the second roll is odd? So for this, we're just looking at outcomes, and we say we have 3 possibilities to get an even number on the first roll, and 3 possibilities to get an odd number on the second roll. So once again, we multiply them to see that we have 9 different outcomes where the first is even and the second is odd. So what's the probability of rolling an even and then an odd? Well, there's a couple ways to see it. Number 1 is saying there are 9 outcomes that make me successful out of all my 36 possibilities, because there's 6 on the first, 6 on the second, so there's 36 total. And we get probability of 1/4. Another way is to say, well, what's the probability of getting even? And then the probability of getting an odd. Well, the probability of getting the even is 1/2. The probability of the odd is 1/2, so we get 1/4. This is the probability multiplication rule. And what it states is that if we have the probability of event A and B, we want both of those, these are independent events, we can just find the probability of A times the probability of B. So in this case, 1/2 times 1/2. Let's try this one. The bag contains 2 red and 3 blue marbles. Robert selects a marble from the bag, looks at it, and then puts it back. So we still have all 5 marbles. Then he selects a second marble. What's the probability he will select a red and then a blue? Well, that's what we want to figure out. Probability of red and blue. These are my two events. So I'm going to find the probability of red first, and then multiply it by the probability of getting the blue. So probability of red is 2 out of 5. Probability of blue is 3 out of 5, and we multiply them. And we get 6/25 of a chance of getting red first, and then blue. Another one. There is a stack of 52 alphabet cards, 26 uppercase, 26 lowercase. What's the probability of choosing an uppercase vowel? Well, we could go ahead and say there's 52 total, and we know that there's 5 vowels, and or there's 10 vowels total, 5 of them being uppercase. So we could say, well, my answer is 50 seconds. There's another way to go about this, using the probability multiplication. So we have the probability of an uppercase times the probability of getting a vowel. So, first of all, we have half of the deck being uppercase. And a vowel, well, there's 5 out of, or I should probably say 10 out of the total 52 that are vowels. 5 in each uppercase and lowercase. And so we can simplify this in a couple ways. We could say 2 goes into 2 once, into 10 5 times, so we have 5 out of 5 out of 52. Okay, so probability multiplication. A couple more examples here. 2 number cues are rolled. What's the probability of rolling a number greater than 4 on each number cue? So we want probability of greater than 4 and probability of greater than 4. So getting greater than 4, that means a 5 or a 6. So we have 1/3 chance in each of these cases. So we say that the probability of getting both of them greater than 4 is 1/9. Okay, and I think this will be my last example here. A coin is tossed and the spinner is spun. Find the probability of tails and a blue, and then we'll do tails and not blue. So first we need probability of tails, and that's of course 1/2. We'll multiply that by the probability of getting blue. It looks like we have 1/3. So that's 1/6. Probability of tails is still 1/2 here, and not blue. Well, that means we could get gray or white, so that's 2/3. And we would say our probability of getting both is 1/3. Okay, and I guess this one will be my last one. Coin is flipped 4 times. What's the probability the coin will land heads all 4 times? Well, we need probability of heads times probability of heads times it twice more. Okay, and for each of these, the probability is 1/2. So when we multiply that up, we say 1/2 times 1/2 times 1/2 times 1/2 is 1/16. We have a 1/16 chance of getting heads all 4 in a row. Well, I hope this is helpful for your homework and for study.